So in this session, we explore some known regenerative infrastructure designs and day-to-day practices that we can do to live in a regenerative way, and some of the precedents of eco designs that people have applied in creating regenerative architecture. And after that, I think we'll dive a bit into the current projects that I'm working on and just some of the more framework design and concepts about the project. So let me just share my screen. Okay, sweet. Um, yeah, so I prepared the slide, and it's called Permaculture as a Spiritual Science. Wait, I don't know if I go this way, can you still see my screen? Wait, just gonna wait. Actually, give me 1 second. Let me redo the sharing so it's okay. Now it's better. Permaculture is a spiritual science. So as I was delving into the idea of regenerative living, regenerative agriculture, and I realized that like regeneration, it's such a multidimensional concept. It can be applied, to different aspects of life, and so I was like, okay, like it's a very big and broad subject, and it's also very abstract. Like, what does it really mean to be regenerative? And one thing led to another. Permaculture has been a subject that came up multiple times by people I met and through the research that I've been doing, where people be like, oh yeah, you should check out permaculture. And there's also people say, oh, permaculture is not really a scalable solution. So I've known what it is for a while, but I haven't really delved deep into what really is permaculture. And I started like really reading about permaculture and see, the heritage of where this whole studies come from. And it was just very, very mind blown by the amount of intricacy that goes to a really good permaculture design and its principle. And actually, a lot of the permaculture design, for me, I think it's a very spiritual way of understanding the land, understanding the environment, understanding the plant, understanding our human needs. And it's a very holistic system. And people say that permaculture is hard if you do it right. And I completely agree, because for all the like it's really rare to find permaculture templates online that just like tells you everything that you need to know to grow everything that you want to grow. There is some templates that's very ready tested, like plants combinations that usually will work in different areas, but the whole science itself, it's very complex. And so today we're gonna do sort of a dive into just the whole world of permaculture and why it can be considered as a spiritual science. So before we dive into permaculture, I wanted to share with you this recent new discovery of this book that I found out. It's called The Tao of Physics, and it's written by this professor, whose name is impossible to pronounce, Fritjof Karpa. And he kind of like drew a lot of similarities. So he has a background in physics, and he also has a personal passion in Eastern mysticism. So he studied like, from quantum physics to Eastern religions, and he basically drew the similarities between these fields and the complementary thinking methods in between these two fields, and it summarized all of these in this book called The Tao of Physics. And the name completely caught my attention. I was like, okay, like let me read what does he have to say. And then I found this book to be super inspiring and very rational, but and also rational logical analysis of the two fields and how they can be, like very helpful if we kind of practice the thinking of combining the two together. And we wanted to share with you guys some of the like the takeaway, like the golden nuggets that I've summarized from this book. And basically what he was saying, that in Western science was built upon this foundation, or Western modern physics and modern science is built upon this foundation equates mind to wisdom. You know, like maybe the original like thinking pattern came from this really famous quote from, I think it's Descartes, or like, not, I might not be correct. I think therefore I exist, where a lot of like the pursuit of modern Western science believe that, oh, like only the things that can be proved and tested and observed are the things of reality, and everything else are just incorrect or like irrelevant. So but this mindset has in return caused a highly separated and compartmentalized society, and we'll dive down into why that's the case later. So yeah, like the second quote is basically explaining why that has led to a highly separated and compartmentalized society. But basically, the natural environment is treated as if it consisted of separate parts to be exploited by different interest groups. So we have different scientist groups that are interested in one aspect of nature, and then they really want to understand this one aspect of nature. But then nature itself, it's complex and it's very interwoven, like a web of life, where like one thing doesn't work because of the thing itself, but it's usually because it's interconnected with all these other things. And in modern science, because we separate the rest and we only focus on like the one specialized part that we want to focus, um, it usually causes us to actually lose the grasps of the things that are actually matter, and then focus on the things that we think matters. So the beliefs that all these fragments in ourselves, in our environment, in our society are really separate can be seen as the essential reason for the present series of social, economical, and cultural crises. This is something that I highly agree. It has brought a glossy, unjust distribution of natural resources, creating economic and political disorder, an ever rising wave of violence, both spontaneous and institutionalized, and an ugly, polluted environment in which life has often become physically and mentally unhealthy. So, for example, to bring this to relevance to farming, because we will look at one crop like wheat, and then we think about, okay, how do we mass produce wheat so we can feed as many people as possible, so we will never be able to starve. And then we started to just grow wheat everywhere, and then we look at the nutrition table of what wheat need, and then we just produce these nutritions in the form of fertilizer, and then like just grow massive amount of wheat. But by doing that, we are not utilizing our environment efficiently, because we're neglecting the fact that actually all plants survive the best when they're living in a very diverse when they live in an environment with high biodiversity. There's all these things. There's like tall plants, medium plants, lower plants, ground cover, fungi, like little worms and birds and animals, and all these things create different types of nutritions, and then they kind of feed each other into this interwoven complex web of nature. And then if we separate that and be like, only, oh, we don't really care about all these plants. All we care is just one plant. And let's just see how we can grow as many plants as possible. And then we might be able to successfully grow a lot of plants of that same kind. But at the same time, we're causing detrimental effect to the environment around us. And we're consuming more energy than we need by manufacturing an environment that's artificial just in order for us to achieve maximum yield of a certain specific target. So this is kind of this philosophy that this Professor Fridtjof Karpa summarized in this book, which I think that it can be applied to actually a lot of phenomena that's happening around us. And the last part, he was saying, physicists know that their methods of analysis and logical reasoning can never explain the whole realm of natural phenomena at once, because nature is just so insanely complex and intellectual that we cannot just like summarize a portion of it and be like, oh, this is how nature works. Now we understand, because the wisdom of nature is like so divine and beyond our common realm of understanding in most cases. So yeah, physicists have to separate nature into parts that they can comprehend and test understand in order to have a grasp of nature, which is, it's it's not saying that this method is like wrong, or we shouldn't use this method of thinking anymore. But as we apply these kind of scientific thinking, we should also realize the limitation of these thinking. As we do experiments that separate the rest of the environment, we should operate with this mindset, like not forgotten, knowing that like this is a separated experiment. This is just a study of this one thing. Just because this works in this enclosed ecosystem doesn't mean that it's gonna work out there. And yeah, so scientists like single out a certain group of phenomena and try to build a model to describe this group. In doing so, they neglect other phenomena, and the model will therefore not give a complete description of the real situation. That's what we see very often with like the progression of our technology so far and the progression of scientific development, how it's applied in commercial uses, whether it's growing plant, whether it's creating energy, whether it's recycling waste, all these things. And what he touched on the aspect of Eastern mystics is that the Eastern mystics repeated insist on the fact that the ultimate reality can never be an object of reasoning or of demonstrable knowledge. So this is like kind of repeated in a lot of different religious texts. One of the really famous one is the Tao that can be told is not the Tao. There's many ways to really understand and interpret this quote, but a really common way of interpret that is that nature is so divine and complex, and we can understand it scientifically as much as we can, but there's also parts of nature that are understood with more intuitive knowledge rather than analytical mind. And every time the physicist asked nature a question in an atomic experiment, nature answered with a paradox. And the more they tried to clarify the situation, the sharper the paradox became. So this part he's actually talking about more recently in the development of modern science, mostly with relativity theory and quantum physics. Before relativity theory and quantum physics, the scientific realm was very kind of like Newtonian. Like everything was made of actual substances, and like there's like energy conservation, and then like what you everything is kind of like very very quantumized. And then until the recent discovery of quantum physics, it completely changed how even people in the scientific world view our world as large, because they realize that deep down, like at the basic building block of nature, things are very organically designed, and also there's a huge amount of uncertainty into like the way atoms and a nucleus and all these like little building blocks of our life behave. Like there's the famous double slit experiment where like these things behave differently if you're looking at them or not, and then that just triggered a whole wave of experiment and debate on like what really is composing the fundamental of our reality. And actually a lot of that kind of correlates with the teachings of ancient mystical religions, even though like there is still like not really like a proven summary of these theories. But a lot of the ancient Eastern kind of mystical religions have been proven that it can even be used to reflect on a deeper side of our reality. Well, it can kind of like it basically has been adapted more, and then people, I guess, like that used to be very hardcore Newtonian physics believer started to see the really true diversity and unpredictability of nature. And as we penetrate into matter, nature does not show us any isolated basic building blocks, but rather appears as a complicated web of relations between the various parts of the whole. The whole universe appears as a dynamic web of inseparable energy patterns. In modern physics, the universe is thus experienced as a dynamic, inseparable whole, which always includes the observer in an essential way. In this experience, the traditional concepts of space and time, of isolated objects, and of cause and effect lose their meaning. So a lot of times, like, our fundamental knowledge and belief has been built upon these templates and textbooks, and that we had to remember growing up as a kid, and then we believe that they they manufacture the realm of like the foundation of reality. And as we progress to discover, you know, more side about reality, in a scientific approach as a whole species, and we realized that a lot of the fundamental beliefs we had actually were incomplete. And because they were incomplete, that all of the technological development that we have under that incomplete theory also have room to grow so much more and also adapt to new theories as we understand the universe more and more. So these are kind of like the takeaway from this book, The Tao of Physics. I really strongly recommend everyone if you're interested in either of the field, because I know like a lot of, I guess, like modern analysis of ancient religion can be kind of very subjective, but I think in this book the author did a pretty good job, like, like actually going back to a lot of really solid references and then making very logical analysis of both worlds. And so I really recommend. So yeah, like all of that theory that I mentioned, I think can be, like reflected into a lot of the ways we've developed into kind of this post-capitalist society, right? Like farming, for example, is just one aspect. There are so many other aspects, such as, like the fashion industry, how we shop cotton, how we do clothes, and like in all these different industries, we have seen how profit maximization has resulted in a detrimental effect to the environment, and also like a detrimental effect to the industry itself. Like after you maximize your profit by exploiting the environment, maybe you made a lot of profit in a short amount of time, but then after that, as your soil start to degrade, as your environment, the land that you own and operate on start to have worse and worse health condition, and you have to put more and more pesticide in order to keep it going, eventually it's not a positive sum game anymore, because you need to just, like you've destroyed something that had so much valuable, because so much more value, because you didn't realize the amount of value it had. Like traditional farming completely kind of just disregard the incredible value that soil and natural environment has given to the natural location, and just like completely like wiped everything away and be like, I'm just gonna plant this one plant and then forever and ever and make any same amount of profit. But then in the long run, it has been proven that it's actually more and more costly for you to, keep the same operation going on. And then after you plant the same kind of crop for a while, you've completely drained the biodiversity of that area with this one crop. So what a lot of farmers do is that they will plant the same kind of crop for a few years until the biodiversity is completely changed, being adopted to that kind of crop. It will attract a lot of pests, so they have to spend more on pesticide and then cause their product to be questionable. And after that, because the soil is so like not able to be used by the same plants, they have to like basically take out all the plants and plant another type of plant that has different soil needs to like increase the diversity of the area. So like essentially there's a lot of work you have to do into maintaining this cost, because you just went ahead planning without actually listening to the environment and listening to nature and seeing how things should work. And that basically is the fundamental concept of permaculture, which, as I was learning through permaculture, I just realized how much of a beautiful, beautiful subject and mentality it is. So yeah, now we're gonna dive into permaculture and see what are some of the fundamental principles of this, and how it can be applied to like things inside the world of agriculture and also outside. And yeah, and there's actually a slight difference between permaculture. It doesn't really just mean organic gardening, where organic gardening can be just like, okay, like I'm gonna plant different plants in different sections and then they're organic. But permaculture, essentially, it's a way to design an ecosystem so it lasts on its own without too much of human interference. Just gonna take a water break. Wanted to see some Some chats, yes, all facts. I agree. I really was like mind blown by just this whole study and everything. Excuse me. And so I was Googling about permaculture and I was looking for, like what are some of the fundamental principles? How do you operate? What are some of the design examples? And this book and this author kept coming up from all the websites I've been doing. And basically, a lot of the current websites that talk about permaculture principles drew inspiration from this book by Bill Mollison, who's kind of a very, very like well-known scholar in the permaculture world. And this book is called Permaculture Designer's Manual. And I was very, very like interested into this cover because it looks like very it reminds me of like some alchemical drawing of the Middle Ages and whatever, and it has these like sacred geometry, infinity symbol going on, and with like pictures of the environment and everything. It just looks super interesting. So I kind of like just did a skim through of the book because I didn't have to time to finish reading the whole thing, but it was very it had a like really really great introduction and also teachings on the mentality of permaculture studies. And just want to spend some time covering this cover story. So the great oval design represents the egg of life, the quality of life which cannot be created or destroyed. From within all things live or express. Within this egg is called the rainbow snake, the earth shaper of Australian and American Aboriginal people. So as we all know, that in Aboriginal culture, snake is kind of like a very sacred animal that reflects like the universal serpent. So there's like a whole deeper cultural heritage to the story and the symbolism of the snake as an animal, where like it also symbolizes um, just the different cycles and loop of the universe, where like the cycle of life and death, the cycle of of growing and decaying, and then the snake, the serpent eating its own tail, kind of has this like very profound implication. And so the story of this cover image is that let me see, where should I start reading? So okay, so there is the legend of the rainbow serpent. In the beginning of earth was flat, a vast gray plain. As the rainbow serpent wound his way across the land, the movement of his body heaped up the mountains and dug troughs for the rivers. With each thrust of his huge multicolored body, a new landform was created. So basically, the serpent was a metaphor of this, how like the creator of the universe. Last, tired with effort of shaping the earth, he crawled into a water hole. The cool water washed over his vast body, cooling and soothing him. Each time the animals visited the water hole, they were careful not to disturb the rainbow serpent. For although they could not see him, they knew he was there. One day, after a huge rainstorm, they saw him. His huge colored body was arching from the water hole, over the treetops, up through the clouds, across the plain of another water hole. To this day, the Aborigines are careful not to disturb the rainbow serpent, as they see him going across the sky from the water hole to another. Within the body of the rainbow serpent is contained the tree of life, which itself expresses the general pattern of life forms. As further elaborated in the chapter on the pattern in this book, its roots are in earth and is crowned in rain, sunlight, and wind. Elemental forces and flows shown external to the oval represent the physical environment, the sun, matter of the universe, material from which life on earth is formed. The whole cycle and form is dedicated, as this book, to the complexity of life on earth. And and so to my understanding, I think the serpent is a symbol of like just sacredness of creation of the earth. And to apply that to permaculture, one really really essential concept of permaculture is reverence instead of reverence instead of exploitation. So it like kind of it I actually applied a lot of mentality from Aboriginal people in Australia to Native American people and the way they approach Earth and do farming. in a way they approach approach the land, and they approach the environment in a form of reverence, where they study the land and the environment first. And then if you combine this mentality to methods of modern science, where like in permaculture, it's like before you even start planting, there's so much work that you should do in order to understand like the amount of details that construct this land that you're about to plant, right? Like how much sunlight is it getting, how many hours, what's the altitude, what's the moisture in the air, how many rainfalls do you have, what is the current soil biodiversity. And understanding all these elements can later, for experienced permaculture master, they can come up with a mental map on what are some of the plants that I should plant first to increase the certain elements in the soil, and what are some of the plants that's complementary to these plants that I can plant together so they grow better with each other. And so I think it's really important to iterate that, like the core principle of this is really like everything that permaculture wants to do or does is evolving around the nature environment, where it comes and it makes edit to the nature environment, but it doesn't take away what's already there. It doesn't really like extract like the beauty that's already created by our mother Gaia, but it adds more element, like more like vibrant and nutritious element to the ecosystem, so that it benefits, in the end, it benefits us humans, as its resident. So here are the ethical basis of permaculture. The number one is care of the earth, where provision for all life systems to continue and multiply. So you're not just growing things for humans, but you're growing things for a whole ecosystem. You're growing things for humans, but you're also growing things for the animals, and you're also growing really nutritious food for the plants. You're growing for the worms to be able to eat food scraps. You're growing for the little chipmunks that are your neighbors. You're growing for the fishes in the lake. You're basically caring the entire ecosystem, instead of just about like you and your family and what you eat, because the healthier the entire ecosystem is, the healthier it will be for you and your family to coexist. Like it's like the law of like a law of cause and effect or correspondence. I would say law of cause and effect. The more you love nature, the more you love the environment around you, the more love you get back from the environment around you. And that's the number one principle of permaculture. And number two principle is care for the people. So like after you make sure that nature is taken care of, you also should take care of yourself. So provision for people to access those resources necessary for their existence. We can't really I think the service to self and service to other has like this beautiful scale that we kind of dance on, where like if all we do is just service to ourselves, then like in the long run we realize that we're not really servicing to ourselves, because it's not really long lasting. But if all we do is service to others, then like we wouldn't be able to be self-sustainable if we just sacrifice everything and then starve. And then you'd be like, oh, I'm not gonna eat anything because I need all the resources to everyone else. And that's also not healthy and sustainable. So it really is a balance of the scale of self and others, and take care of yourself in order to take care of others, and take care of others in order to take care of yourself. And the last part of permaculture, which is something that I had recently kind of came to realization about this principle, it's consume with limits. By governing our own needs, we can set resources aside to further the above principles. Like consumption is kind of an interesting theme, where like it's really I think a relative mindset. Personally, I was born I was born in China, and I grew up in China during a huge economic boom of that time, where like there was a huge middle class being created out of literally nowhere. I was growing up there, like China just created a middle class, in the past 40 years. And there were a huge amount of sustenance sustenance and materials being created, where everyone had abundance, everyone was living better and better, where my family were living from like having no AC, having like barely able to afford a bicycle, and then didn't even have a shower at home, have to go to public bathhouse, to now every single unit have showers, ACs, cars, and everybody have these material goods that were able to support themselves. So like as I was growing up, I've kind of been trained with the mentality where like, oh yeah, these material goods are like, they're necessary, they're completely necessary, and they make us really happy. And like, and then the more material you own, the happier you are usually. Like just had this mentality in me growing up, by like being inside that kind of societal mentality. And at some point, especially during last year when I joined Mars College, which is this desert camping experience, where we were living in sort of an extreme condition where there is no like material pleasure at all. Like you're living in a desert, kind of just like camping for a few months, and you had communal showers, and not that everyone showers at the same time, but there's like a few showers that everyone shares. There's no, beautiful like home decorations. There's no, like Amazon. I mean, there was Amazon, but I wasn't like Amazoning. There's no like, acquiring new decorations for my house so it looks really nice. None of that. And I just kind of realized that the need for consumption, the need for like goods, actually is a huge relative scale where like the more you own, actually, this is such a cliche, but I realized that the more you own really doesn't necessarily make you happier in a lot of ways. And actually, if you were in a situation where you couldn't have abundance of materials, you will make do with what you have. If all you had was just like these rice to eat, you will like figure it out on how to survive on these and might still have a quality life. And so I think that, being in a post-capitalist society, we're very used to like these material abundance. Like I think last time I looked at the statistic was like in the US, like 30% something food are just wasted because people just order and then didn't finish, or they spoil, they go bad. And then for us, it's just like maybe we're just used to it. Go to a restaurant and then like, eat 30% of what you order, and then the rest is just like, and it's just, if we lived that life to be super used to that, then that, not saying that, like that's completely wrong. I feel like this is a very relative subject, but it kind of makes us less aware of, or less appreciate less of the stuff that we already have. Like if all you have is just, like a small amount of food to eat every day, and it's really good food, and that's all you have, I think you will like appreciate it so much more than compared to if you had like 10 meals a day or something like that. So like this concept, I think, in permaculture can be applied to, like general lifestyles as well, but especially when you apply it should be applied to the planning of the environment, where like that amount of consumption really like matters a lot in the long run, and matters a lot in the bigger scale when you think about constructing a village and a city. If if we can practice to be just like very aware of what we actually need, and instead of like consume what we can actually acquire, I think in the long run it makes a huge difference, as a collective, as a community, but also as individuals. So yeah, sorry for the long like run on that subject, but I felt like that was needed to be pointed out. So this is a quote from the book where, for the sake of Earth itself, I evolved a philosophy close to Taoism from my experience with natural systems. It is a philosophy of working with rather than against nature, of protracted and thoughtful observation rather than protracted and thoughtless action, of looking at systems and people in all their functions rather than asking only one yield of them, which a lot of these are so similar to the Tao physics by Frigga Karpa, which actually had a lot of similarity in the way they approach systems and like look at science in like in a particular angle, and of allowing systems to demonstrate their own evolutions. So it's really going back to mentality of Native Americans when they approach land. It's really like the priority of the prior mentality is reverence over exploitation. Like you recognize that nature has created such a complex and beautiful system, and you study it as much as you can to understand it before you even start to like dig a shovel and then completely change things. So this is kind of the concept of permaculture, and it really is not easy. Like people say permaculture is hard, it's not scalable, and I totally agree because there's like in order to be a master of permaculture, you have to be a master at many sciences. It's kind of like have to kind of train yourself to be a polymath. You have to understand how the climate works, understand how soil works, how each plant works, and these knowledge have been studied for a good amount of time, where people summarize patterns that we can learn, from just browsing the internet. But still, to be really like deep in, or to be an expert at permaculture, it's really not that easy, and it's not about just like like getting a degree or something like that. I think it comes with years and years of training and actually planting and understanding the environment around you. And I certainly am like nowhere even close to that. I'm only just reading from these masters and what they say and translating these to the audience. But I still think that like this is a whole field needs to be revered. And yeah, before we get into some details, I wanted to share with you, if you're curious about this whole subject, um, I recommend this film called The Biggest Little Farm. And I saw this film a while ago, and it's basically, let me just reshare my screen real quick. And it's about this couple that wanted to start a farm in LA. And so they bought like a few hundreds acres of desert land. You know how Southern California is. It's like not the most fertile land. And then they basically, throughout almost 10 years, they completely transferred this deserty land into a beautiful permaculture forest, where they did that with a lot of support and with from like other experts who really had experience understanding nature and understanding the environment. But in this farm, they documented the process of transferring desert land into like a beautiful permaculture forest, eventually having its own kind of little ecosystem. Where in the end of the film, it mentioned how like California had these 3 day like crazy hurricane rainfall, and all the land around this farm were washed out because the soil was just so dry. And then when there's like crazy hurricane, soil just gets washed into the ocean, and then all the crops just died. But their farm stood strong because they have planted so many different diverse groups of plants, had so many different animals, different like biodiversity on this land, that like their land was not affected by the hurricane at all, because they completely just changed the environment throughout this careful planting and planning into designing the system. So it's a really, really beautiful story, but it also just showed you how incredibly difficult it is to actually know like how things work, and how to make the ecosystem work in a cooperative way instead of like more individual way. So this, just wanted to shout this out real quick and recommend people, if you're really interested in the subject, strongly recommend this film. It's a really feel good film, and it kind of like brings a lot of inspiration and hope to the space. And also, if you happen to be in Southern California, you can actually visit them. They do take visitors, so that part is really exciting. And they give farm tours, and then they kind of teach you about their story. So yeah, really great work these guys have done. And so now I'm gonna give some examples of permaculture, and then basically I've been studying these for the Agartha project, which I'm working on for the Forefront Residency. And as I mentioned before, it's a little video game that's trying to, I guess, teach principles about permaculture and principles about eco-village and eco-living. And as I'm building the system, I realized there's actually a lot of stuff I need to learn. So this is the stuff I've been collecting as I was learning. And so yeah, I would like to share with you guys just very briefly, and then maybe dive into the actual design of the game later on. I think we'll still have some time. Um, so one of the classic plant guilds is the Three Sister Guild, and it's the guild that Native Americans use a lot to grow plants. So it has three sisters. It has corn as the center of the guild, which is the main really long plant that has the most amount of yields, and it has squash being planted around the earth, forming a layer on the floor on the ground, and then basically gives soil like a decent amount of courage and coverage, and also like provides a different like diverse different kinds of nutrition into the soil. And then you have the beans which climb around the corn, so then the beans have corn as a support system where it can climb upon, while the corn has bean have and as a support system to be protected. So this is just one example of like what are some of the applicable ways of applying permaculture principles. And this is other like another more complex kind of diagram of permaculture principle where like usually in permaculture, a good ecosystem is an ecosystem that has diversity of all different kinds of plants. So you have tall tree, you have small tree, you have little shrubs, you have root vegetables, you have herbs, you have ground covers. So they are usually vines and a lot of times strawberries and little wildflowers. And then you have fungi, which is like essential to different nutrients of spreading nutrients around the ecosystem, because as we all know, like it's fungi has been really popular recently. And then fungi, like they're on the surface they're just a few different mushrooms being spreaded around, but whenever you start to have fungi in your ecosystem, they actually build a massive intelligent network, like the mycelium network underneath. So this mycelium network lets mushrooms communicate to each other, but also brings nutrients and carry them around and nurtures the entire ecosystem. So they're actually super essential to the ecosystem. So this is what a really good permaculture forest would look like, which is have all these elements of different types of plants. And another useful permaculture design thinking is to design in a way that it's the most efficient, and design in a way that makes sense, right? So like these examples, for example, if you are planting a water tank, you place it uphill so that the water comes down and with gravity, so you don't have to spend extra energy pumping water into your household, right? If the condition allows. And if you have a deciduous tree, and if you can plant that right next to your house, facing the north, where there you have a lot of sun, and and that tree would block the sun during summertime if you get really hot summer, and then when the tree is dried and dying in wintertime, it leaves more room for the sun to penetrate into the house. So these are just like examples on like as part of like permaculture design thinking, where you can strategically design the environment in a way that it's energy efficient for you, for the house, and also for the environment itself. And another example is that outputs of one element are inputs for another element located nearby. So in nature, there is no such concept of waste. One person's waste is another person's food. And that's pretty much also essential in the permaculture design principle, where we want to form these feedback loops of energy transferred. And so this is a really simple experiment, where a simple graph where it shows like, the garden that you grow is gonna provide food and vegetables for you. And then you use that, and then the leftovers you feed that to a worm farm, which worms love eating just, like even like expired or like spoiled food or whatever, any like kind of food scrap. Worms will eat it up, and then the worm casting, which is just a fun name for worm poop, literally looks like soil, and then they're just the most rich kind of fertilizer, organic fertilizer, can be applied back to the kitchen and allows the food to grow better. So in this way, there is really no waste in this whole system if you do it right. And and these are some of the more examples where like if you plant your vines in certain direction, it gets maximum amount of sun, and it's not unevenly spread. And as I was studying this, I kind of just realized how these are all like they're all like still just data, right? Like if you can do a simulation where the sun, you can kind of like vaguely calculate, like how much the direction of the sun, and then you can kind of use this environment to educate the designers that maybe these are the better ways to arrange your plants instead of the other way around, by by creating a design mechanism that would allow these better design to produce better results compared to vice versa. So as I was looking into these principles of permaculture design, I was like, oh, this feels like actually a puzzle game of life. You know, like it's not just something that you can like read and then just like kind of copy paste and methods from other successful examples. You really have to be thinking about that for your own environment, for yourself, and that's not an easy challenge. But what if we can just encourage this kind of design thinking in like a simulation where like as kids are playing games, they can also learn like principles that actually can be used in real life. So yeah, these are some of the more examples of where it comes from. And this is a great example about willow tree, where willow tree, they're beautiful to look at, and then but they also have this great ability of reducing wind. So if you happen to have strong wind coming from the riverside, which usually if it's a vast lake, then usually the wind from a lake is going to be stronger than wind on land because there's no blocker, there's more aerial space. And if you plant a willow tree where there's wind coming, then you can protect the rest of your crop from being kind of like blown away by strong wind, not the crop but just the soil itself. And it can help like plants having like a more solid foundation. And then the roots of willow tree can also provide fish habitat and filter water. So there's like all these things. It really like once you understand the features of each plant, you can start to like just maneuver these plants around as elements of the universe and see what problems is this element solving, which element works well with this other element, and then start to like make connections and then build environments that are sustainable, and also build an environment where things cooperate with each other in a way that reduce work for the farmer, for the builder in the long run, right? Like if you build a system that like people are like feeding, like elements are feeding each other and helping each other out, in the end it's less and less work for the farmer to have to take care of it like consistently. And this is another example of like the water cycle, where like the rainforest, the rainfall of the water, could be used. The rainfall of the water can be used for people to, like drink and clean, and then great water can also great water from leftover from like cooking or from drinking, or from showering and all the stuff, can also be great resources for trees and shrubs, and then go naturally into the ground, and then like and then the water gets filtered and everything. So anyways, this is like another example that we'll dive deep later. And this is a website that I would really like to recommend, Deep Green Permaculture, and it's kind of how do I say, really a lot of really like well summarized permaculture principles are kind of demonstrated in this blog, where like if you don't have too much time but you still want to understand how everything works, this blog is a really great resource. And it's like I would say like each page is just a 5-10 minute read, so like you pretty much just spend like an hour or so reading the whole thing, and it's really well summarized. And another great example about permaculture design is earthships. I think I actually plan to have like a whole session about earthships. So maybe this session we just keep it short. But the whole design of earthship is basically it's called earthship because it's the entire ship that has these like very beautiful like feedback loops of energy and water and waste consumption and everything. And it utilizes the environment and utilizes resources super consciously, and creates like a whole holistic like ship that can be self-sustainable and also completely off-grid. So earthship design is pretty much just like the golden standard of sustainable and like regenerative living design. And there's like different types of iterations of earthship, and it's also built upon completely recycled materials. Um, so I would strongly recommend looking into earthship, and this is also like what a lot of the inspiration of the game and the systems of the game is going to be drawn from the design of earthship, basically seeing how it works. And this is one of the pictures on what it looks like. It looks really nice inside. And if you want to like know just the very like the whole founding story of Earthship, I really recommend this movie Garbage Warrior about Michael Reynolds. And then he talked about how he, the journey of him building Earthship and wanting to build sustainable buildings and how much of a hard struggle it was. It spent like, 10, 20 years just like figuring out the right prototype. And also after that spent like 10 plus years fighting legal battles because the legal structure in some states in the US are so strict that it doesn't really allow people to build anything experimental in a way that I think it's kind of counterintuitive because that kills a lot of new routes for innovation. But anyways, he like summarized the whole legal battle story in the movie as well. And it was a very like heartwarming story to see, and then just see how much he struggled and the result, how much of a beautiful result they've created with this invention. And so now we're gonna delve into a bit on like permaculture and holistic environment design for an eco village. Like all those principles, like sounds really nice, but like how do you actually do it? Like what are some of the things that are needed? And I know we don't have too much time, but I would like to go over maybe like 10 minutes if that's okay. If we have time, like I would like to go over just like 10 minutes and then because I do want to spend more time like talking about just the blueprint and building plan for this game. Just let me know in the chat if that's okay. If not, we can schedule another session. No worries. That's okay. Okay, that's great. And so I'm gonna stop sharing the screen and going to share another screen. I'm gonna share my Figma gem of the game structure. Well, before this, I should share another Figma gem. Sorry, I have like 5 Figma gem for this. So this is the Figma gem for a solar punk village. And these are the things that I've been thinking about in terms of building a solar punk village, which solar punk just really means that you're using technology to, in a way that's like human centered, and you're using technology to create holistic regenerative environment. And here are like the things that we talked about. For example, the flows. I think I have a better graph. Okay, these graphs first. So from water flow, which we mentioned earlier, like water can be captured with rainwater capture, and then you can use that for drinking, cleaning, and then the waste goes to garden, and then like it goes back to the garden, and it goes back to the clouds, to the environment. So water itself can have this like holistic like loop set up. And same with okay, this is like same, these are all water. And the same with energy flow, right? Like you have, and you collect energy from solar or wind or some other renewable resource, and then you can use that to heat up your shower. You can use that to like operate on your day-to-day maintenance, use it to do computer work, Wi-Fi, all that good stuff. And then but you can design your system in a way that allows things to flow more efficiently to save energy instead of like the other way around. So with the example that we saw about having water tower at a taller place, and then have that naturally flow downhill. So these design principles should be encouraged in the simulation, where people can like think about applying like things in a more clever way to avoid energy use. So like we can really combine on these elements and then design some graphs that the players to figure out what's the most efficient way to grow things, what's the most efficient way to distribute energy, what's the most efficient way to to like distribute food and all that stuff. So these are like very rough idea that I worked on a long time ago, and this I think I shared with this during the forefront pitch. So want to share, probably just do a bit more deep dive right now. So these are like just the vibe pictures I've been collecting for residential housing. Some of them are not real, but some of them are, and some of them are made with like mixed adobe structure, which is just a new form of clay created by straw and rocks and sand. But basically, a lot of these building materials can be collected locally, and collecting local material is also a huge principle of permaculture design, because you're eliminating the carbon waste of shipping stuff from overseas. And even though like I'm not gonna say that we should completely avoid any carbon footprint, that everybody should just stop traveling right now and only stay at home. Like that's not, we also don't really need to go that far, but you know, as much as we can, I think it's good to be aware of the cost of these materials. And this is a beautiful example of African vernacular architecture, where people just used local clay to build these really beautiful little adobe looking houses. And yeah, and then earthships and all that stuff. And so basically this is the village blueprint design, where we have residential housing. Every residential housing support a certain amount of population, and then we use that to support people, and then people might have their own needs, you know, they have to eat, they have to drink and all that stuff. And then that comes from like functional housing. So from like rainwater tank to collect rainwater and then being used for residential uses. And here are some really cool design of rainwater collection. So this is a beautiful tower, I think designed somewhere in Southern California. It looks completely insane, and it's massive, and it's a whole rainwater collecting tower, where like each of these layers collects amount of rainwater every time it rains, and then it gets funneled to the city. So like something like the rainwater could be designed in a very beautiful, kind of inspiring way. It doesn't really necessary to just look like that, you know, like not like, or that, you know, like it could be something more inspiring, you know, could design to be more like a flower. But anyways, like we can, or it could design into these more organic shapes and things like that. um, and then the rainwater can be filled into a food forest, which should be essential in an eco village, where you have like this beautiful permaculture forest, where you know there's like all these diverse group of plants, and have that be able to sustain the like needs of this village. And then all village will probably need a waste station. So each waste station have different ways of processing waste. You know, we can range from just single composting to biogas. Biogas can also provide for yeah, this is more of a biogas chart, and can provide for village for people to cook and for use. And aside from that, there can also be cafe for people to co-work and, you know, like, and hang out and socialize. And aside from cafe, you know, we can have the standard yoga studio and all that stuff. And also really important to have a creative workshop where people can exercise on idea and build things. And the better workshop you have, the more creativity you can fuel into the residents. So, and then like last but not least, we should have a really good, well thought of electricity in energy system, where, you know, you can, this is actually a lot of these calculations already exist online. But if you can calculate the amount of people you have in your village, let's say if it's a 20 people village, the amount of appliances that you use every day, you know, from like washing machines to maybe cooking to, you know, computer work to like electric drills to lights, and then do a whole summary chart of like how much that would cost, and that would determine the size of your solar and the size of your battery. And then each of these also have its installation cost, its lifetime. But basically all of these can be summarized into kind of hard coded code and data in a simulation, where you can kind of use that to kind of like plan out like, oh, like if I have a village of 5 people, maybe this is the amount of it. And all of those are like actually applicable skills in building real life applications. Like when people do their van life conversion, the first things, one of the first things they need to learn is just energy consumption and solar intake, and also water usage, right? So like everyone that I've met and talked to that does full-time van living, like tells me about how important it is for them to calculate the amount of water they spend every single day, and then use that to estimate the amount of water they need to refill every other week. And also same with energy, like how much solar are they getting, and then like how much energy are they storing in the battery. Condition changes, if they're in a desert, if they're in like somewhere that's more cloudy, like things change, and then use need to be very like well calculated. So all of this I feel like could be super fun to be applied to a little game where you can kind of just like um, learn actually like useful knowledge, but also like in a really playful way. But I know like so far everything that I've covered probably sounds just like really, really ambitious. At least to me, it sounds really ambitious, and it also sounds like almost unrealistic because as we covered earlier, nature is just so incredibly complex. How do we have like how can we capture this entire complexity in a mirrored like puny video game? Like that's not possible, and I'm aware of that, and I want to acknowledge like again and again that it's impossible for us to capture the entirety of nature. What we can do is really only abstract on what we can understand, and then use that as building blocks for us to understand more and more about the environment around us. Although the best way to learn is probably to actually do it, to submerge yourself inside an eco village or inside a food forest and actually learn how growing works and how everything like learn by practice. But not that like the whole reason that we want to create this video game is because not everyone has the time and energy and also the opportunity to do that sort of learning right away. But in the meantime, when we go by our day-to-day life, we can access or at least have a gateway towards this lifestyle through like playing some sort of playful virtual simulation of a certain kind. So that's the intention of this game. Play to learn, yeah, not play to earn. Is there a functional reason why the SC tower is designed in that shape? I think I'm assuming that you're talking about the water tower over here. So as I was reading the blog post, it's designed in a way that it's actually like if you look at from the side, it's actually super tall. So, and then it has all these different layers. So there is functional reason of designing that way is that when a lot of times when rainfall, it doesn't just fall straight from the ground, so it falls from the side because of wind. So when you design like this like spherical structure where it has these layers of water capture system, when rain falls from all different angles, you are able to actually catch a lot more than just the regular rain catcher, because in this you're only catching kind of like straight rains that's fallen straight like ahead, but you're not really catching on the side. So if in a way this is actually a really like really it's not sustainable, but like really well designed or really utilitarian design, but also like combining the form and the function into like one really beautiful piece. So yeah, really inspired from this idea. And okay, no more question. Okay, and then now I'm gonna share with you another another Figma board, which is the board about the gaming structure. So designing a game is not an easy task, and designing a game that aims to kind of replicate all these complex knowledge is like even less so of an easy task. And because the first week at the Forefront Residency, I've really been spending it mostly doing like artistic renders and style guide for this village, because that's what inspired me the most. And so I haven't had a lot of time and like going super deep into the game mechanism, even though like I've been working on this full time for the past few days. And so what I'm showing right now is kind of a work in progress thought process onto this system, where like I want to think about things in terms of game objects. And it's basically this is a process of translating like the knowledge of like like natural knowledge and then into like like a very simplified video game version. So in the core principle of video game design, everything is treated as a game object. Like the environment is a game object, your character is a game object, the anime character is a game object, and the food that you eat, the health pack that you pick up, the weapons that you use are all game objects. And then when you shoot things out, like usually in games there's not really a real bullet that's traveling because that's very I don't know, like unnecessary to be calculated. When but basically game design is just a whole system of interactive game objects and the rules of how they interact with each other, right? So in a first person shooting game, you have your player character object that have a weapon object, and then they walk around, they see the enemy object, and then they shoot the enemy, and then enemy object has different features, and one of the features is the amount of health they have, the amount of defense they have, the amount of attack they have. Same with players, you have the amount of health, defense, attack, and then maybe the attack changes when you have a different weapon, so like each of the weapon have its own elements. So and then when player shoots an enemy, then like the weapon, like the computer will fetch code from the data on this weapon, and then see, okay, this is X type of weapon, and this has like 20 damage to certain amount of enemy, and then it sends data to the enemy character, and then see enemy character had 100 health, and now we're gonna minus 20. But if enemy character has this special ability that like has like +5 defense against this kind of weapon, then maybe minus 15, and then that gets reflected on the energy bar on the enemy character, and then you see that like blood dropping. So that's kind of like how game design works in on the back of what's rendered on the screen. So before we really got into the screen, we really need to think about the engineering structure of this game. Like what are the elements? What are the interactions? What are the manager database? And where are the data stored? Where is the data structure? And it could be a really complex and intimidating thing to do. Like I've been just feeling kind of intimidated for the past few days, where just like I work for a few hours and I would just be like, oh my god, this is so hard, where do I start? So this is pretty much a work in progress, but I would still like to show you. So because the whole idea is very complex, so I try to summarize and like simplify and simplify and simplify into like individual objects that we can start kind of like prototyping around. So one of the classes that we have is going to be the object class. The object class, each object has a name, has a category, like maybe a type, what it is, and it has an ability to be manipulated. So like each object will be able to be dragged, be dropped, to be spawned, generated into this map, and then it also comes with a value cost. So like how much does it cost to generate this object, and then later you can utilize this cost into a summary of like how much budget you have, and then like if I have a certain amount of budget, maybe I shouldn't plan that much lion's mane because I couldn't afford it, and I should plan to like shiitake instead or whatever. And then the unit size, and then the 3D model, which is the look, like the actual like what does the object look like. And then for plant is a type of object. Soil is also a type of object, and air can also be a type of object if you like divide the world into like kind of a I think vexel system like Minecraft, where every unit is a little cube. So if you think about air as an object, then the air object would have like qualities such as, I think I have, yeah, like a block of air could have like X amount of oxygen, X amount of CO2, X amount of H2O, and then also like 100 different other elements that we're not gonna cover in here. We're only gonna focus on these 3 elements, and then these 3 elements are gonna be affecting the environment around them. So like as you have a block of air into like an environment, permaculture forest that you're trying to plant, you can kind of use that to affect the plants that's growing here. Like what kind of plants need how much amount of CO2 in the air, and then use that to determine the longevity and the health of the plants, and also how much plant is emitting, how much oxygen is to the environment based on the amount of nutrition it's getting, and that can change a block of air. So basically, let me see if I can just like maybe, so basically you have a block of air, a block of earth, so soil, and then like maybe a block of plants. And we also have like human consumption, but we can get to that later. And then you can just start to see like, what are some of the nutrition value in the plants, what are some of the nutrition value in the soil, and how is this plant going to add nutrition value to soil, and how is the soil going to add nutrition value to plants. So it's like really like the whole system is like, by nature it's like it has this effects to the systems around them. And then in a game we can kind of try to summarize or try to observe how things work, right? And then this helps us kind of understand a bit more like how nature works, even though not completely, but at least like it provides just an opportunity for a prototype. And yeah, and then like when it goes to the environment, like what are some of the default environment that you can provide people. So this is a really cool biome pyramid that I've summarized. So like environments when you have two axes from wet to dry and hot to cold, and then you can start to have like, by having certain combination of wet, dry, hot, coldness, you can create like just kind of generate these different kinds of environment, even though there's like it's a lot more complex than just the summarized graph, but this is somewhere where we can get started. And so we can say like environmentally, maybe the default, if we have like right now we have an object class that have all these elements and the energy cycle. I'm gonna put this somewhere else. And then we can also have a climate class where it's a different type of class, and then it has a biome of like water amount. So water amount, density, sun amount, and temperature and elevation. And then hot and cold, and that's kind of like just the temperature parameter. Wet and dry, it's like the water amount parameter. Once you have these like as the fundamental block of the environment, you can use that to determine what are some of the predestined objects on the environment before before you actually start to do the permaculture and planting. So these are like the design of nature environment before human interference. So this is something that I've summarized into like basically the principle of this eco-village design is that like, before we actually start to move everything, the game itself should have a fundamental data on like what the natural environment is, like hot, cold, how dry, and then also should have data about like fundamental elemental things about like the four elements of like kind of our unit, like of Earth in a way, where fire represents the amount of sunlight, water represents the amount of water, earth represents the type of terrain, and air represents maybe like wind, cloud condition, like how fast are elements moving around the environment. And then once you have these figured out, like kind of in terms of just regular parameters, and then you can have that you can give an opportunity for players to start to estimate like fire, for example. If you know amount of sunlight, you can use that to affect your energy use calculation, right? Like if it's a place that gets a lot of sunlight, maybe solar makes sense. But maybe it's a place with a lot of wind, maybe wind energy makes more sense. And then that gets reflected into the way you coordinate and plant, and then plan out your village. And also like that will be used when you actually make a village in real life. Same with water, like how much water can you catch versus how much water do you have to possibly externally import. If you live in a desert, you can build the biggest rain catcher, but you just don't have that much rain. Then what are you gonna do? Not live in a desert? But maybe there's other ways for you to, maybe you do have to consider like taking the water from external environments or find the nearby lake and things like that. So really going back to the elemental design of the environment, and then turn that into puzzle games of problem solutions, or like games to prompt solutions to certain problems, and then to create like livable situation. Because and the same with like earth, with like building shelters, raw materials, planting food, and then same with the air element. So inside of the object categories, want to go back to this chart. We have like the plant categories, which is something that we're primarily focused on for this purpose of this demo, because we probably don't have time to do everything. And then each plant can have like input and output. So input means like what does this plant require in order to be healthy, and then like soil acidity, soil nutrition, the NPK ratio, nitrogen, phosphorus, potassium, and the space that those plants need in order to grow, and elevation, like the amount of air density, and some plants do well, like, and then amount of sunlight and all that stuff, and output of the plant, like how much nutrition do you give to the environment, how much nutrition do you give to the resident, and what are some of those specific type of nutrients that you producing. So in permaculture, there's these plants that's called nitrogen fixers, where they have special ability to bring nitrogen in the air into the ground in order to produce more nitrogen-rich ground. But nitrogen fixers should be probably planted with plants that need a lot of nitrogen, and plants versus plants that don't need a lot of nitrogen, right? So like, how do you actually figure out this puzzle and make it right? And same with like soil and air. And before we like finalize today's session, I just want to create one more thing. So as we mentioned earlier, the principle of game design. In the principle of game design, there's the idea usually of object classes, custom classes, and idea of character classes. So in a classic first time shooter, like character is like your like you have humans, you have enemies, but in this example, I think for eco villages, we're only serving humans. Maybe we're serving animals at some point, but primarily let's just think about humans and animals in this example. So yeah, sorry, I think I didn't like quite summarize today's agenda, but I did plan to do a bit of a life planning. So this is the result of that. Hope that's okay. And okay, yeah, we're almost there. So humans, for example, you also have input and output. So input is kind of we can summarize it as needs, and output, right? So each human have like certain amount of needs that we need to fulfill based on like just common needs, like water amount, how much water do we need to drink every single day, and nutrition amount, like maybe like calories, energy, and the amount of like protein and vitamins and all the good stuff, and then other blah blah blah. So like we can know on average like how much does each individual need to consume every single day, and carbohydrate, like don't forget about that. And then we can use that to plan out our garden to see if it's actually enough to sustain our residents. And we need water amount and nutrition amount, and we also need to think about energy usage. And this is also like an average of like how much energy that you're using. And then basically like like ideally people can live without electricity. There's people that do that, there's Amish people that do that, so it's not really like a must. Maybe this can vary it from like 300 watt a day to like I don't know, like 7,000 watts a day, like if you are like running wash cycle and things like that. But these are the needs, like maybe basic needs of humans. And then in the end, like we can think about like time. So like a lot of the building and the maintaining of the village takes a lot of time for people to maintain. And then so in a way that the residents are probably like obliged to maintain the village at first. But the more free time you can give to people by creating smart, intelligently designed village, maybe that like free time, we can just like say free time would increase happiness. For now, like it's not really necessary, but this could be like one of the examples. So you can measure like how much free time every resident have, and then use that to correlate to like personal freedom, and also like the free time that your resident have means that they have this time to explore what they love to explore. So these are the needs, and then we can say these are the humans also have effects. So what are some of the effects? So like energy usage is a need, but also effects. So let's say humans have waste. We can give it a quote. So we produce organic waste, right? Like poop and pee into, and then we think about like the amount of poop and pee that's produced by every person. I know it's really gross to talk about, but it's a reality that we have to think about. And how much this human waste can be used and needs to be converted in order to give back to the ecosystem, and also like help facilitate or like help grow the ecosystem. So we have that, and then we also have labor. So each human also have X amount of time to be able to maintain things, and this is also where you can make the game really fun, because that if you go super ambitious and design a really massive amount of like fruit forest, and then you have like three residents living on this eco village, that like the three residents are gonna just be so tired every day, and they're gonna be like the Sim City character, not Sim City, the Sims character, and they're like gonna be so stressed and complaining and be like, oh my god, I hate you, why do I have to work 12 hours a day harvesting all these crops? So like maybe that also helps training our design thinking to be more aware of our use and aware of like the scale of our operation. So as of right now, I would say the effects, I would just say it's waste and labor, and also like building, like living shelter. So like the amount of spaces that you use for humans, it's basically the place that you're not gonna grow food or anything, and you also need to have a lot of materials in order to like build structures that's stable for people. So all of these should be considered, and they can also they also have like an effect on the environment. So basically these are just the structure, the engineering structure of what this game would have. And I've already kind of started out like drafting out some of these into basic game objects, custom objects. And I think, okay, I've kind of gone a bit over time now, but I think now will be a good time to make a stop, because next session I will be going over like a more technical deep dive into this video game, like how do we design it, what's the ins and outs, and I'll be able to show some of the assets I've been creating and the environments that we've been building. So more details will be left to next session, but this is just like a getting started kind of planning. And also a lot of these might or would definitely go through changes, but this is just a way for me to understand like what needs to be built before we actually start to write code and then draw things onto the virtual ground. So with this, I think I want to bring an end to today's session. If I'm just gonna stop sharing, and is Nate here? Hello?
Yep,
Oh, hi.
we can.
I'm ready to